This is our final project for ME475, and on the right you can see the bike frame that we analyzed. For the analysis, we used a simplified beam element model and a representative model that is more accurate. We used three different materials for the bike frame: steel, aluminum alloy, and magnesium alloy, and here are the important properties.
For the first load scenario, we looked at if a user was climbing onto the bike. For both the forks and the frame, we considered it to be steel, and this resulted in a combined weight of 8.86 pounds. We saw a maximum total deformation of 0.00335 inches at the pedals and a maximum equivalent stress of 87,000 psi located by the seat. In order to understand how the material affects the results, we did multiple material combinations. In this case, we did aluminum forks and steel frame, and that reduced the weight to 7.5 pounds. We saw a slight increase in the maximum total deformation to 0.00367 inches and a maximum equivalent stress of 8,800 pounds. Next, we looked at a fully aluminum frame, which reduced the weight to 3.13 pounds, 5 pounds less than the steel frame. And we saw that the maximum total deformation tripled to 0.0094 inches, and the maximum equivalent stress actually decreased to about 8550 psi. Additionally, we looked at a fully magnesium frame, which reduced the weight again to 2 pounds. We saw a maximum total deformation of 0.015 at the pedals again, about 50% increased from the aluminum, and a maximum equivalent stress of 8,400 psi. The next load scenario we looked at was a road bump on the front wheel. So the back wheel was fixed and the load was applied on the front. We saw a maximum total deformation of 0.06 inches and a maximum equivalent stress of 42,000, and this was for a fully steel frame. It was also analyzed with the material combinations seen before. The maximum total deformation and the maximum equivalent stress locations were the same in every material. However, magnesium had a significantly higher maximum total deformation and a slightly higher maximum equivalent stress. The frame was also analyzed for a road bump on the rear wheel. It saw a maximum total deformation of 0.035 inches on the rear wheel and the maximum equivalent stress of 47,000 psi. The last load scenario was a drop load of 150 pounds on the seat location, and the loads resulted in the same maximum total deformation and maximum equivalent stress seen on the road bump on the rear wheel.
Using the beam element model, we did a modal analysis where the front and back wheels were fixed and there was a point mass on the seat, and you can see here the first 12 modes from that analysis. For the climbing on the bike scenario, we looked at the harmonic response, and we looked at the response in the X direction at the joint located beneath the seat, and we looked at the response in the Y direction at the pedals. We also looked at the harmonic response for the road bump scenario on the front wheel, and these are the results in the same locations and directions from the previous slide. We looked at the buckling for two different scenarios. For the climbing on the bike scenario, the load multiplier was about 5,100, and for the road bump on the front wheel scenario, the load multiplier was about 105. We did a joint analysis for the drop load, and we looked at the handlebar and pedal joints, and here are the results.